We first loaded the molecules in from zinc. We then did a lig prep to prepare the ligands, then we ran quick prop to get the pharmacokinetic and more so physiochemical parameters of the molecules. Okay, we're going to go down to the jobs that are finished over here, which are SP ketamine 1, SP ketamine 2, and SP ketamine 3. And we're going to find those files in the directory that we used. Okay, here's the Schrodinger directory. There's SP ketamine 1, SP ketamine 2, and SP ketamine 3. I'm going to open up a new Maestro. And to drag the output files, when you double click the file folder, make sure you're grabbing the .pvmaegz files, so the pose viewer files. Those are right here. Click it, minimize, quick hold, drag. Okay, there's the first file folder. We still need to grab SP ketamine 2, the PVMAEGZ, and then lastly we'll grab the third output file, PVMAEGZ, SP ketamine 3, right here. Okay. We're gonna now go to project table. Once I go to the project table, you can use the drop down menu to collapse each tranche, PVMEGZ 1, 2, and 3. I'm gonna hold command to select all the files in that folder. Right click. I'm gonna ungroup the groups. I'm gonna sort everything. Scroll all the way over to docking score. I'm gonna hit the arrow, ascending. Okay, now everything's sorted by docking score, so we can look at the docking pose of some of the higher higher ranking ligands. I don't want to use the word affinity, it's not that. Higher docking score ligands. I'm gonna delete out 2 of the PDB files and just keep 1. To make the docking poses a little bit easier to see, I know that there are some co-crystallized ligands still in the PDB ID because I left them there. 1 of 2, I'm going to select ligand, edit cut. Makes it a little bit easier to see the ketamine bonding site with the ligands bound. Style, I'm going to change that to ribbon so I can see the PDB ID a little bit better with the experimental compounds. And now I can look at some of the higher ranking ligands. Maybe we'll look at 10. We don't need to look at that many. If I hold command, control, it'll put the selected entry in the file. Here's the top ranking ligand from the Glide SP job. It's got the protonated amine. It's got an aromatic halogenated ring. It's got another protonated amine. If we want to toggle on the molecular interactions, we can click to do so right here. That'll show us the molecular interaction between the ligand and the binding pocket. Just do a quick observation here. Let's see what comes up. For molecular interactions, there's a lot of backbone. There's a few backbone interactions which usually aren't that important. But there is this hydrogen bond with ASN 614 hydrogen bond between the C double bond O carbonyl and a hydrogen coming off of one of the protonated amines. Right? The other ones are backbone, so I don't really care about those too much. kind of want to just batch select the first 10. Just kind of curious what some of the top 10 ligands look like. Binding pocket. Sometimes I like to look at them in a group like this so I can see kind of the common molecular interactions. Okay, so we kind of do see, with the Gladys P jobs, we do see this hydrogen bond with threonine 648 come up quite a bit with a few of the ligands. And the other meaningful one is ASN 614. Okay. The other ones are backbone. We typically don't count backbone that much because the backbone of the backbone residues aren't that flexible, but the side chains are more flexible. Oh, this is actually, whoa. Oh, wow. Fascinating. You can kind of see, this is very interesting. There's two within the 10 by 10 by 10 grid. There's sort of a few ligands that are binding to a pocket in this region of space, and there's a bunch of other ligands that are binding to a pocket in this region of space. That's kind of unique. I don't see that a lot on screens, to be totally honest with you. And I think you know what that really suggests? That really suggests that you could actually could probably fit bigger ligands in this binding pocket is what this suggests. Now I'm wondering if you bump the size of the molecules up more, could you make a larger ligand that's going to occupy the site? Huh. You may have to run a screen for some larger ligands to find out. It's interesting. Let's put 20 in there just to see. Yeah. Would you look at that? I'm kind of curious what this, there's like, well, there's not like, there is this sort of structure within, if you look at it right here, it's almost like, it's not you wouldn't call it indole, but it does have that 6 carbon ring, 5 carbon ring. It's got 2 nitrogens inside of there, imidazole ring. There's a functional group name for that. I'm really curious what that ligand is because it's kind of bridging both binding sites. This is it. This is the one. It was kind of it was occupying sort of those both sub-binding pockets that we saw before. Kind of interesting. If you want to see the structures of, let's say, the top 100 molecules, we can quickly do that with the 2D viewer. Structurally, a lot of these molecules are very, obviously these are pretty similar compounds. These are, just looking quick, I would say these are analogs of one another. Just kind of curious as we scan through. This was the one that was occupying both sites. Well, not both sites, but it was bridging both of the areas the site was occupying. These are all relatively small molecules that also likely, because I've worked with, I would guess that some of these with the protonated amine, they're fairly small. These would probably also bind to GABA, honestly. GABA receptor, if I had to just take a guess. That's kind of an interesting ring system. The cubane ring system. This one's interesting. This one's interesting because it comes up. It's just a funny molecule. It's like, what is it? Cubane. It's literally just a three-dimensional cube if you think about it. All carbons at each intersection if you think about the corners of each cube, called cubane. Very interesting molecule. And it has been made. People have made cubane before. Another cubane. Yeah, CF3, that comes up quite a bit in pharmacology too. All right, so anyways, the last thing I want to do before I end this video is I want to run the last job, which is glide XP with expanded sampling. That usually gives us a little bit better binding poses. They're actually based in the co-crystallized ligand, but for now I'm going to kind of assign them somewhat randomly. I'm going to run XP advanced settings, expanded sampling. I'm going to call this 7EU7 7EU7 underscore glide XP ES underscore 1. The ligands, make sure you select them. Usually rectum are in batches of 1,000. That runs pretty fast. Batches of 1,000. I'll probably run about 5 jobs. I'll just see what the score is like. Okay, and that's where we'll end today's video.